a short work by Adelbold, Bishop of Utrecht, of the Order of St. Benedict, on the method of finding the volume of a sphere, addressed to Pope Sylvester II.
This work now appears for the first time in print, from manuscripts of the celebrated monasteries of Tegernsee and St. Peter's in Salzburg, through the efforts of the Most Reverend Father Alphonsus Huber, monk of Tegernsee.
Preface.
To Lord Sylvester, Supreme Pontiff and Philosopher, Adelbold the Scholar wishes perpetual life and happiness. It is a grave offense to disturb someone devoted to the public good with private requests. But I trust in your ability to attend both to the needs of the Commonwealth and to answer what I am asking. And yet I act rashly, and I sin knowingly, that I, a young man, approach so great a man as though he were my fellow student. But confession of sin not only seeks pardon, I say, but demands it. Perhaps you think that I sin in such a way that I do not wish to repent of having sinned, and therefore my confession, being without the fruit of repentance, should neither seek pardon nor demand any remission. To this I will respond that if I offend your kindness in this approach, I will regret having approached you more than you could believe. And therefore I judge that pardon ought to be granted to one who grieves and repents, who confesses his sin, and who wishes to abstain from such offense in the future, especially by one who holds the place of him to whom it was said, as recorded in the Gospel of Matthew, chapter 18, verse 22. I do not say to you 7 times, but 70 times 7. But if I do not offend, and if I seek what I will obtain through your good will, since in obtaining it I will rejoice to benefit both myself and many others, then regarding the questions I have already sent to your authority, since they have not been answered, I either fear that I have offended you with them, or I hope that something great will come from the delay in their solution. But I will not propose yet another question, so that either from what I fear I might grieve more, and the magnitude of my grief might move you to pardon, or from what I hope I might rejoice more, and the fullness of my joy might implore future reward for you. And indeed, regarding what I now wish to propose, I seem to see by what reasoning it can be analyzed and brought to understanding. But I await your careful attention to settle the matter definitively, so that the authority of so great a man may either correct or confirm my understanding. What the problem is, then, and by what thought processes I am both misled and held to certainty concerning it, I will now reveal, so that once the wound of hesitation is opened, the medicine of certainty may be ready from you.
Section 1.
Macrobius, in his commentary on the dream of Scipio, where he speaks about the size of the heavens, earth, sun, and moon, and their spherical roundness, says that it has been discovered by the most expert geometers that with 2 circles, if the diameter of one is double the diameter of the other, the volume of the circle whose diameter is double is 8 times the volume of the circle whose diameter is half. To find the circumference from the diameter from the circumference, and the area from the diameter and circumference, and therefore to compare diameter to diameter, circumference to circumference, and area to area. This is easy for those who are accustomed to dealing with such matters. But how can someone compare volume to volume who has not yet grasped what volume is? For the comparison of 2 things does not precede knowledge of them, but follows it. Hence it happens that one cannot understand that one volume is 8 times another volume if one does not know how the volume of each sphere is calculated. What I have already understood from this I will reveal, not, as they say, teaching Minerva her letters, but to show what I think, so that if I err, I may be led back to the path by your wisdom, or if I hold the path though stumbling, I may be supported by reliance on your authority. But to reach what I aim for, I will begin with things that are known to many.
Section 2.
I take a diameter of 7 feet. From this, I find the circumference as follows. I triple it, and add 1/7 of that tripled amount to it, and thus I have a circumference of 22 feet. Now, when I multiply half the diameter, which is 3 1/2, by half the circumference, which is 11, I get an area of 38 1/2 square feet for this same circle. So now I have the diameter, I have the circumference, I have the area. But to find the volume, I cube this same diameter, and I construct a cube of such a kind that it touches the roundness of the sphere on its faces, but exceeds it at the corners and along the lines running from corner to corner. From such a cube, it is necessary to cut away that volume which extends from the spherical surface to the corners and lines, so that when this is cut away, only the solid volume of the sphere remains. I make this reduction in the following way. I divide the total of the whole cube into 21st parts. From this I take 1/21st part of the cube, which is 16. I multiply it by 10, and I have the portions cut away from the cube. Then by 11, and I have the volume of the sphere. That is, from these 21st parts I assign 10 to the excised portions of the cube. The remaining ones I leave to the volume of the sphere. This would be the same if I multiplied the total of the whole cube by 11, and from that product subtracted 1/21st. For this 21st part is as large as those 11 21st parts that were taken from the simple cube.
Section 3.
To make what we are saying clearer, we will assign definite numbers to two volumes so that we can compare the assigned values to each other. Not because these are more accurate, or because we believe you are ignorant of them, but so that having shown our methods to your careful attention, we may henceforth be guided by you and not go astray. For a circle whose diameter is 7 feet, I find the volume as follows. I cube the diameter and say 7 times 7 makes 49. Again, 7 times 49 makes 343. Behold the cube of that square whose each side is 7 feet, and this cube completely encloses the spherical volume. But to cut away the excess portions I do this. I take 1/21st of 343, which is 16 2/3. If I multiply this by 10, I have 163 1/3, namely the excess portions of the cube. If by 11 I have 179 2/3, namely the volume of the sphere. To make what we are saying more evident, let us draw a circle within a square, so that what is seen in the plane may be more easily understood in 3 dimensions. Behold, in this sphere the diameter is 7 feet, the circumference 22, the area 38 1/2, and the volume 179 2/3. Now it is not surprising if the cube obtains nearly half of its volume in its excess portions, since this square in the plane retains scarcely a third in its projecting portions. For in this square, when each side is 7 feet, it will have an area of 49 according to the measurement of the sides. And when the circle has taken 38 1/2 of these for itself, the square will retain only 10 1/2 in its cutaway corners.
Section 4.
Why this seems to me to be so, if it is not tedious for you to hear, will not be burdensome for me to say. For here is what happens. If the square is raised upward 7 times in height, it yields 343 cubic feet, carrying upward with it both its excess portions and the area of the circle. For 7 times 10 1/2, that is the excess portions, makes 73 1/2, and 7 times 38 1/2, that is the area of the circle, makes 269 1/2. But 73 1/2 and 269 1/2 make 343. Therefore, raising the square upward is nothing other than carrying along with it its excess portions and the area of the circle. Therefore, from that cube which had risen from an area of 49 square feet, if someone cuts away 7 times 10 1/2, that is 73 1/2, he has not yet achieved spherical roundness, but has established something shaped like a bushel measure, carried from equal circular area to equal circular area, namely into 269 1/2 cubic feet. But from this cylinder we should remove not half, lest it be sharpened on both sides like a spinning top, but 1/3, which is 89 3/9, in order to shape the sphere. But this third part, together with the corner excess portions, though not yet completely spherical in form, that is, 89 3/9 plus the 7 corner excesses, that is 73 1/2, yields the same as the 10 21st parts which were removed from the whole cube in order to round the sphere on all sides. And these 10 21st parts would nearly reach half of the cube, except that 1/42nd part of the same cube prevents it.
Section 5.
Now it is easy to see, since the square does not surpass the circle by even a third of itself, why the cube exceeds the spherical volume by nearly half of itself. But this cylinder-shaped form, which is rounded by cutting away the sides of the cube on all sides, although it cannot be fully represented, let it nevertheless be illustrated to some degree, so that what the inadequacy of words conceals, the truth of a drawing may reveal. Behold, it can be seen how much must be cut away from the middle of the cube after the removal of the pointed corners, so that the pure spherical volume may remain. Behold, enough seems to have been said about how the volume of a sphere is calculated from a diameter of 7 feet. Now let us establish another, which comes from double the diameter. Let the diameter be 14. I cube this. 14 times 14 times 14 makes 2,744. This is the cube enclosing the sphere. If I take 1/21st part of this, which is 130 2/3, and multiply it by 10, I get 1,306 2/3, and by this amount the cube exceeds the sphere. But if by 11, it makes 1,437 2/3, and this is the volume of the sphere. If anyone wishes to shape this sphere by the same reasoning by which we shaped the previous one, that is, to derive it from the cube into the form of a cylinder, and from the cylindrical form into its spherical shape, he will be able to round not only this one, but all spheres, from whatever diameter they may proceed, in a similar manner. But let both circles be drawn, both the one which has 7 feet in diameter and the one which has 14, so that the number of each one's volume written beside it may demonstrate how much the smaller is exceeded by the larger. The diameter and circumference of the larger sphere are joined to the diameter and circumference of the smaller in a double proportion, the area to the area in a quadruple proportion, but the volume to the volume in an eightfold proportion. For twice 7 and twice 22, which are the diameter and circumference of the smaller, make 14, and 14 is the diameter and circumference of the larger. And 4 times 38 1/2, which is the area of the smaller, makes 154, which is the area of the larger. And 8 times 179 2/3, which is the volume of the smaller, yields 1,437 2/3, which is the volume of the larger.
Section 6.
Now indeed, I would have no doubt that this is the method for finding the volume of a sphere, if it were unique to spherical volume alone, that when the diameter is doubled, an eightfold increase is found in the volume. But I find this same cause and reasoning in all cubes. For if I make one cube from 2 and another from 4, because 4 is double 2, the cube of 4 will be 8 times the cube of 2, and likewise the area of 4 will be quadruple the area of 2. And not only in cubes, but the same is found also in the depths of wells. In all these matters, if I err, I pray that I may be led back to the path of truth. If I hold the path, I nonetheless ask that the way which holds me doubting in darkness may shine forth, illuminated by the authority of your assent.